Hi Year 9, this is exercise 1204, finding the unknown side using tangent ratio. So what we are doing with this exercise is that you have done questions 1 to 5 previously, and so now I'm talking you through how to do questions 6, 7 and 8. So with question 6, you were to do A, B, E and F. So what I'm going to do is I'm going to do questions 6, C and D. So for question 6 says determine the value of D correct to 1 decimal place. So for question 6C we have our triangle here. Now remember we're trying to use our tan ratio of tan theta equals opposite over adjacent. So we have our triangle drawn and we have our angle that our sides are in respect to. So what we want to do is we want to label our triangle using H, O and A. So we're going to say that this is our hypotenuse as it is opposite our right angle. Our opposite side is opposite our angle and our adjacent side is next to our angle. We then want to write out our trigonometric ratio for tan, which is tan theta equals O over A, and then we want to substitute these all in. So what we get is we get tan 35 degrees equals our opposite side of 10 over our adjacent side of D. So what we want to do is we're trying to solve for D. So that means we want D to be by itself. So what we're going to do is we're going to times D on both sides. So then we get D times tan 35 degrees equals 10. We still don't have D by itself, but it is in the numerator. So then what we want to do is we want to divide both sides by tan 35 degrees. So what we are left with is D equals 10 over tan 35 degrees. What we do is we put this into our calculator. So we go 10, fraction button, tan 35, close our bracket, and we get 14.28, 148007. And we have been asked to answer this question correct to 1 decimal place. So to 1 decimal place it is the 2, however that 8 is greater than 5. So D will equal 14.3 as we round that 2 up, and it is in the units of meters. What we could have done back here is going from our tan 35 degrees equals 10 on D is we could have done something which I like to call a switcheroo. So that means that our tan 35 and our D swap spots. See how originally up here we have tan 35 and D here? Then in our final answer, our D is where our tan 35 is and our tan 35 is where our D is. So what we can do to save time and lines is we can just make them swap spots like so. For question 6D, we are going to look at which angle we have been given, which is 49 degrees. We are then going to label our triangle. So our side opposite our right angle is called our hypotenuse. Our side opposite our angle is called our opposite side, and our side next to our angle is our adjacent side. We then have our tan ratio. So tan theta equals O over A. So we're going to substitute in our angle, our opposite side, and our adjacent side. So we'll have tan 49 degrees equals our opposite side of 8.6 over our adjacent side of D. Now we're going to do that switcheroo to save spots. So our D is where our tan 49 is, and our tan 49 is where our D is. We're then going to put this into our calculator to find our value of D. So we go 8.6 fraction button, tan 49 degrees, and when we do that we get 7.47586 5945. and this is to 1 decimal point, which is the 4. However, that 7 is greater than or equal to 5, so it rounds the 4 up to be a 5. So it'll be 7.4, and our units are in meters, so we write our answer in meters. For question 7, it says a ship out to sea observes a lighthouse on top of a 70-meter cliff at an angle of 3 degrees. How far out to sea is this ship? Give your answer correct to the nearest meter. So we have a 70-meter cliff, which is here. We have an angle of 3 degrees, and we're asked how far out to sea is the ship. So we want to know what this distance here is. So I'm going to call that distance D for distance, and it's in terms of meters, as our other side is in meters. And we have been asked to give our answer to the nearest meter. I'm then going to draw this picture. Well, a triangle similar to the picture. It doesn't have to be to scale, and I'm going to put all my information on. So we have our right angle, we have 70 meters, we have D meters, and we have 3 degrees. Then I'm going to highlight the angle that we have been given and label our sides accordingly. So our side opposite our right angle is called our hypotenuse. Our side opposite our angle is our opposite side, and our side next to our angle is our adjacent side. So for tan, we have the ratio tan theta equals O over A. We highlight our opposite side and our adjacent side, and we substitute them and our angle in order to find how far out to sea the ship is. We then are solving this for D, just like the previous questions. For question 8, we're asked to find the base of an isosceles triangle if the height is 8.2 centimeters and the base angles is 39 centimeters each. So these are the pieces of information we have, and we want to find the whole base of the isosceles triangle. So what we're going to do is I'm going to draw the triangle. I'm just going to draw the one going out this way. So and put all the information onto this triangle. So we know that this is 39 degrees. We know that this is 8.2 centimeters. And I'm going to call this whole length X, but I'm going to call this length Y, because what X is going to equal is, if this is Y and this is Y, X is going to equal Y plus Y, which equals 2Y. So then what we're going to do is highlight our angle, label our sides, solve for Y. So if I was to quickly label my sides, I have my hypotenuse here, I have my opposite side here, and this is my adjacent side. So I'm going to highlight my adjacent side and my opposite side as they go into my tan ratio, as it's tan theta equals O over A. Substitute in my angle of 39 degrees, substitute in my opposite side of 8.2 and my adjacent side of Y. Do my switcheroo with my tan 39 and my Y to get Y equals 8.2 over tan 39 degrees. Put that into my calculator to get 8.2 divided by tan 39, and I get 10.126156668, and then I want 2 of these Y's in order to get my X. So my X will equal 2 times Y, which equals 2 times 10.126156668. So we go times 2 of our answer to get 20.25231337. However, our question asks us to answer to the nearest millimeter. This is currently in terms of centimeters. So what we have to do is we're trying to get from centimeters to millimeters. So what we want to do, if we were going from millimeters to centimeters, we would divide by 10, but because we're going to centimeters to millimeters, we're going to times by 10. So we're going to times this by 10 in order to get x to equal 202.5231337, and to the nearest millimeter, this 5 rounds this 2 up because it's greater than or equal to 5, so it will be 203 millimeters as our final